Hi, so here we have a problem which was sent by Mr. Pranav from Singapore, and in this problem we have to find the total number of shaded triangles in this triangle, and we also have to find the generalized formula to find the total number of shaded and unshaded triangles in any given such triangle. So how to solve this problem? Yes, I'm going to solve it using triangular numbers. Here we have one unshaded triangle in the base, and here we have two unshaded triangles in the base. Here we have three unshaded triangles in the base, and in this drawing we have total four unshaded triangles in the base, and in this drawing we have total 1, 2, 3, 4, 5, 6 and 7 unshaded triangles in the base. So let us assume the total number of unshaded triangles in the base as n. Okay, so the total number of unshaded triangles over here is 1. Total number of unshaded triangles in the second drawing is 3. And total number of unshaded triangles in the third drawing is 6. And the 6 is nothing but 3, which was the total number of unshaded triangles in the second drawing, which appears over here, plus 3, which are the 3 new unshaded triangles in the bottom of the triangle. And in this drawing, total number of unshaded triangles will be 6, which are over here, plus 4, that is 10. And all these are triangular numbers, where nth triangular number is given as n multiplied by n plus 1 divided by 2. It is also the sum of first n natural numbers. So total number of unshaded triangles over here will be 7 multiplied by 8 divided by 2, that is 28. If you want, you can count them. And if I talk about shaded triangles, here we have 0 shaded triangles, here we have 1, here we have 3 shaded triangles, and here we have 3 plus 3, 6 shaded triangles. So the number of shaded triangles is actually n minus first triangular number. So here number of shaded triangles will be equal to sixth triangular number, which will be equal to 6 multiplied by 7 divided by 2, that is 21. So if we have a big triangle whose base has n number of unshaded triangles, then total number of unshaded triangles will be equal to n multiplied by n plus 1 by 2, and shaded triangles, number of shaded triangles will be equal to n minus 1 multiplied by n divided by 2, that is the n minus first triangular number. And total number of triangles, if we talk about, it will be equal to n multiplied by n plus 1 divided by 2 plus n multiplied by n minus 1 divided by 2. So this will be equal to n square plus n square minus n divided by 2, or this will be equal to n square. So you just have to count the number of unshaded triangles in the base, and then you square that number and you will get the total number of these small triangles. And yes, if I count the total number of triangles over here, I just have to add the number of unshaded triangles and the number of shaded triangles in each drawing. So here I'll get 1, here I'll get 4, here I'll get 9, here I'll get 16, and here I'm getting 49, which is equal to the square of 7. This is equal to square of 4. This is equal to square of 3. This is equal to square of 2, and this is equal to square of 1. So it is actually a very interesting problem. It is a simple problem, but very interesting problem. And actually there is one more possibility in this problem. We can also find the total number of possible triangles in this given bigger triangle. That is actually a slightly lengthy method, which I am going to cover in the next video. So for that video and many more interesting videos, keep watching Math Smart, subscribe to it, and don't forget to press the notification bell, because then only you'll get to know about my new upcoming videos. So bye bye till then.